Right, I want to just quickly run through decimal places. If we have 2.491 and I set to 2 decimal places, what would it be? 2 point what? So you have to look firstly. You have to look firstly at the value at the second decimal place. Okay, and then check the value after it. If the value after it is 5 or more, then you round off the 9. Okay, otherwise, if it's not, you leave it as it is. So if I said 2 decimal places, what would it be? In this case is what? 2.49. Suppose I said 1 decimal place now. Suppose I said 1 decimal place, I'll be looking at what? Right, I'm looking at the 4. If the value after the 4 is 5 or more, we round up the 4 to 5. So it becomes 2.5. All right, just make a note right now, please. All right, so that's a quick little thing on decimal places. I'm gonna just make sure you catch this. Try this one, 3.578. Put 2 decimal places and 1 decimal place. I know it's easy, but today's an easy class, right? All right, let's go. What you all got for 2 decimal places? 3.58 because the number after 7 is more than 5. And 1 decimal place. 3.6 because the number after 5 is more than 8. Nice. So you're all good to go there. Now significant figures. Here's where we make mistakes. All right, significant figures. Plenty rules. We have to make sure we understand all these rules, right? So the first rule is that all non-zero numbers are significant. I mean, we know that non-zero is like 5 and 1. So all non-zero numbers are significant. Next, zeros between 2 non-zero digits are significant. So see that 0 in the middle there? That 0 is significant. So zeros between 2 non-zero digits are significant. Coming to the complicated part now. Leading zeros are not significant. Right? So look at that. Look at this one here. 0.0045 only has 2 significant figures in maths. Physics is a little different, right? But in maths, 0.0045, the only significant figures there are the 4 and the 5. This 0, this 0, this 0, not considered to be significant. Next one. Trailing zeros to the right, and here's the important thing, decimal. Trailing zeros to the right of a decimal are significant. So you see this here? See how you have 4, 5, and you have trailing zeros, right? These are not trailing zeros because there's a 0 before it. Okay? Trailing zeros. So after the 4 and 5 and decimal place, all these values here are significant. So if I ask you, if I gave you 45.00 and I said to write this in terms of 2 significant figures, what you do is this. Write 4, 5 and leave out the decimal place. Okay? So 4, 5 is 2 significant figures. Once you put that decimal place, those other zeros become significant. All right? Right? Trailing zeros in a whole number with a decimal are significant. That's kind of like the same thing here. And trailing zeros with no decimal are not significant. So you have to say that decimal place is what will make them significant. But I want you to write these 2 rules here. 3 and 4. right? I have two numbers there, 3200 and 3200 point with a decimal place, right? How many significant figures here? First one is how much? 2, right? No decimal place. So those two zeros on the end are not significant. That's okay? But if I put in decimal place, how many significant figures we have? 4. All right, so there are some other things that we need to know. You don't really see them as much in maths, right? But there are some quick rules that we need to remember, right? Commutative, if you have x plus y is the same as y plus x. So all it's saying is this. If I give you 2 plus 3, that'll give you the same answer as 3 plus 2. That's okay? Same thing if you multiply. 2 multiplied by 3 is the same as 3 multiplied by 2. Okay? So if they tell you something commutative, it means that you can switch them around and work it out. All right? Quick question. 5 divided by 2. Is that commutative? No. Because 2 divided by 5 is not the same thing. Right? Only addition and multiplication commutative. All right? Associative. So if you have 2 plus 3 plus 4, you can add here first or you can add here first. Right? That's the associative rule. Distributive is the expansion rule, basically. X by y, x by z. So if I give you something like this, you can multiply 2 by 5 and then 2 by 3. Right? Things we know already, but sometimes they might ask you, what does this represent? Right? And that's the distributive law. They will ask you, what does this represent? That's the associative law. Most times, the popular one in maths is commutative law. Okay? In one of the years, they even ask you, what is the additive identity? What does additive identity mean? It means that if I give you 1, right? What do you add to 1 to get back 1? 0. So that 0 is called your additive identity. Right? Let's say you have to get the additive inverse, right? Let's say 1 plus what will give you 0? Minus 1. Right? Minus 1 is called the additive inverse. One of the years they ask you what's the additive identity, right? So you need to know those things. What about multiplication? If I give you 5, right? What do you multiply by? There's a mistake. That should be x. What do you multiply 5 by to get back 5? 1. So the multiplicative identity is 1. What do you multiply 5 by to get 1? 1 over 5. Right? 1 over 5 is called the inverse of 5. When you flip 5 on 1 over, they get 1 on 5. Right? It don't always come, but you need to know 1, 2, 3, 4. Those 4 are important. Okay, so we have to learn all of them. Make sure you know. So what's the additive identity? 0. Right? What's the multiplicative identity? 1. All right, let's try this 2 here, June and John. Notice you don't have to work it out, just put it in the calculator. How much you got there for the first one? 3 over 4. Right? Put the next 2 parts in the calculator, 2 decimal places, so part 2, and the exact value for next part. Okay, well, what you all got for 2 decimal places? 3.84. 3.84. And what you all got for the next one? Exact value. All right, 2.88. Let's go again. Let's try next one. Let's try this one here. Using a calculator, let's get those values and let's practice the one with the 3 significant figures. June 2014. Right, so the first one is what? 350? 350. And next one is what? 2.55, nice. And the last one to 3 significant figures is 15.7. Right, 2 here. Let's do a standard form because I want to show you about standard form, right? What you all got for the first one? 7 over 18? 8. 7/8, right? Again, you still get to use the calculator properly. And what was the exact value here? 0 point. Right. So let's talk about standard form now. Standard form, right, is when you write by 10 to the power, right? But the value that goes in front of the multiply sign must be between 1 and 10. Must be. You can't have a value less than 1 or a value more than 10. So you see decimal place here? We have to move it decimal place such that that value, right, is between 1 and 10. So you're going to move it once to the right, and you will get 4.46. Can you move it 2 to the right? Can you move the decimal place 2 to the right? No, because you'll end up with 44.6. That's more than 10, right? So when you move a decimal place, the value has to be between 1 and 10. So I moved it 1 to the right and I got 4.46. If you move to the right, the power is minus. If you move to the left, the value is, the power is positive. Remember, when you move the decimal place to the right, the power is negative. When you move it to the left, the power is positive. Okay? Let's just try 2 more, right? Standard form. I try and put both of them in standard form. 1, 2, 3. So you move it 3 times to the right, and we got 5.23. 3 times means -3. Okay. Here we go in 1, 2, 3, 4 times. So that'll be 5.23. We move it 4 to the left, so that'll be 10 to the power +4.